All right, we're going to talk about chapter 1.5 today, linear inequalities. Our objective is to solve problems using linear inequalities and interval notation. You've had all this prior, so this is just going to be some recalling and making the problems into college algebra level. So we have greater than, less than equal to, and greater than equal to. With greater than and less than, we have some other specific symbols we use. We use an open circle. We use a dotted line for two-dimensional graphing. This is for one-dimensional graphing, two-dimensional graphing. And for our interval notation, we would use parentheses with that. Okay. Greater than, less than, this basically just means I cannot choose whatever number we're talking about. I can go all the way up to it, but I can't choose it. With less than equal to, we will have a closed circle or a dot for one-dimensional graphing, a solid line or closed line for two-dimensional graphing, and brackets for our interval notation. Down here you can see we've got our types of interval notation. Our types of notation, we have inequality, set builder, and notice the only difference between these two here is this part. That's it. Everything else is the same. Okay, so we're just calling X to become a member of this set. Our interval notation, that's using A and B in the right bracket or parenthesis and graph. Okay. I don't mind which graph you use, the parenthesis bracket or the open and close. Know that the book is going to use this one. So if you want to check answers and that kind of stuff, you should make sure that you're going to look at the right one. Now, in our book, here on page 141, let me flip to it here. On page 141, it kind of gives a breakdown here of how some of them will work out. But I don't want you to know this and try to memorize this because we can figure all of this out without having to memorize it. Okay. All right, so let's look here. Express the following as an inequality, an interval, and a graph. Okay, so we have x greater than negative 3. So we have x is greater than negative 3. So there's my interval. Or sorry, there's my inequality. I need the graph. So we will start at negative 3, 0. We always need 2 points on my number line. I don't care about all the dashes between there. That's not really important. Okay, I have an open circle at negative 3 because I cannot choose it. It is not equal to, and x is bigger than or greater than negative 3. So that arrow is going to the right. And then our interval, the smallest number I can choose is negative 3, but I cannot actually choose it, so I put a parenthesis, comma, infinity, because this line keeps going on forever. So I can choose anything in that direction. B, x less than equal to 5. So then we'll go to the number line. We'll put 5 and 0. It is less than equal to 5, so I have a solid dot. Okay, and less than is to the left. So I've got my arrow in that direction. The interval, well, the smallest number I'm going to choose is negative infinity, and it has a infinity always has a parenthesis because I can't actually choose it. Infinity is a location that is constantly moving. And then the biggest number I can choose is 5, and I can choose that one, so I put a bracket with that. All right, x is greater than or equal to negative 1 and less than 4. So I've got my two numbers here, -1 and 4, and x is related to both of them, so we'll put him in the middle. So x is greater than or equal to -1, so I put that. X is bigger than, so it's opening towards the x, and less than 4, so less than 4. So then on my number line, my two numbers are -1 and 4. It can be equal to 1, so we put a closed circle there, and it has to be less than 4, so I open circle, and we want all the numbers in between there. So there's your graph. Your interval now would be bracket -1, comma 4, parentheses, just based on that graph. I find that it's easy to look at the graph and tell these things, especially that interval, because the interval is just a portion of your graph. You're calling out that portion. Okay, x is greater than or equal to 0 and less than, or equal to 4. So again, we're looking at 0 and 4 and x. So x is greater than or equal to 0, so it's greater than or equal to, but less than or equal to 4. So if I go to my graph, I've got 0 and 4 on my number line. They are both equal to, so I can choose both of those numbers. So we've got filled in circles. And x is less than but greater than 0. So we've got that. So then we have 0, comma 4 with brackets. Inclusively, I can include both of those numbers. We have union and intersection. Okay. With union and intersection, we're talking about sets of numbers and groups, because this is calling out a set of numbers. So some keywords here. Let's start with intersection. You had that in probably geometry here. So the word and if we look at a Venn diagram here, I have set A here, and this will be set B. If we look at the intersection, that is this portion in here. So it's where these two items are overlapping. If we look at a number line, and let's say we've got this here with an arrow going this way, and this here with a number line going that way, their intersection is right in here. Okay, so that's what we will look for with and, or with the intersection. The union, we could also look at overlapping with the intersection. Union is our keyword or, so one or the other has to happen, but we also have together or everything. Okay, so if we look at the union of A and B, that is talking about the entire Venn diagram, everything in here, even the intersection. Okay, so if I've got 1, 2, 3, 5, 6, 7, 8, the union is 1, 2, 3, 5, 6, 7, 8. The intersection is just 5. Okay, the union is every number that I have an option of choosing. Okay, so let's solve some of these. Now, solving inequalities is the same as solving equations except for one thing. Okay, and let's note that one thing right up here. When you multiply or divide by a negative number, you have to flip, so must flip sign. So when you multiply or divide by a negative number, you have to flip the direction of the sign. So if it is a less than equal to, once I divide or multiply by a negative, now it's a greater than equal to. Okay, and we'll see some of those. So here, we're just going to solve like an equation. We'll subtract 5 minus 5. Negative 3x is less than 18. Divide by negative 3. And since it was negative, I'm going to flip the direction of the sign, x and negative 6. Okay, so this tells me here, if I do my graph, so I have negative 6 and 0, open circle negative 6 because it's not equal to, and then we want x bigger than negative 6. So that's going that direction. My interval would be negative 6 with parenthesis, comma, infinity, parenthesis. Now let's look at this a little bit differently, and let's say I don't want to divide by that negative 3. And this will kind of help us understand a little bit of why we have to flip the direction of the sign. So I need to make this positive. So we will add 3x, and we will have 5 less than 3x plus 23, subtract 23, negative 18, less than 3x, divide by 3, x is greater than negative 6, which we got the same answer, okay? But what happened? Well, when I move this x to the other side, I did initially, like over here, I flipped the direction of my sign, okay? It was x less than, now it's x greater than, okay? So we are kind of rearranging that. When we do it this way and flip the sign, we are initially just moving this to the other side, okay? And we could say that if we have an equal sign, let's say we have negative 2x equals 6, and if we divide by negative 2, we could say we flip the sign with that. But if you flip the equal sign, it's still an equal sign because it has symmetry there. Okay, it's got symmetry, so flipping it's the same. Okay, so it really doesn't benefit to learning to flip every sign. Okay, so moving up to kind of a college algebra level. Okay, you notice we have fractions, so to get rid of those fractions, we'll multiply the whole thing by our common denominator, which is 6. Okay, then we'll take that times everything in here. So we will take 6 times 5x over 3, less than or equal to 6 times 4 plus 3x over 2. And I did it this way because we can see now that my 3 can cancel with my 6. So then I have 2 times 5x is 10x, less than or equal to. My 2 and my 6 cancel, and we'll distribute that 3. So then I have 12 plus 9x, subtract 9x. You have x less than or equal to 12. And my interval, there's 12, there's 0. I have a closed circle because it's equal to, and I want x to be less than 12. So that's going that way. So that says negative infinity to 12 bracket. And this will be the answer I'm looking for. Okay. And we're going to look at quadratics. We're going to look at all sorts of inequality type equations. So anything we do this year, we're going to do with inequalities also, because they're very, very similar. Okay, so here you should notice I've got 3 sides. 1, 2, 3. And whatever I do to one side, I have to do to every single side in here. My goal is to get x left alone here in the middle. So we'll subtract 4 from every side. So minus 6, less than 6x, less than or equal to 6. Whoop. 12. Divide by 6. And I do not flip the sign because this number down here is not negative. Even though these numbers on top may be negative, this has to be negative on the bottom. So I have negative 1 less than x less than or equal to 2. So on my number line, negative 1, 2, this is a closed circle because it can be equal to. This is an open circle, and we want the numbers in between. So that's parenthesis negative 1, comma 2, bracket. Okay, I find it much easier to go from here to this interval. Okay, because we're taking the full number line, the infinite numbers, and we're looking at just a portion of that number line, which is right there. All right, 1 less than equal to negative 2 minus 3x all over 7, less than 4. Okay, again, same thing. What I do to one side, I got to do to all three of them. So we want to get rid of this fraction. So we'll multiply by 7. So the 7 gets distributed in there. So I have 1 times 7 is 7, less than equal to 7 divided by 7. Those cancel out. So I have negative 2 minus 3x. Because those went away, you had 7, negative 2 minus 3x over 7. Those cancel out, so I didn't need it. Less than 4 times 7 is 28. Okay, so we're going to add 2 to every side. So you have 9 less than equal to negative 3x less than 30. And divide by negative 3. And when I do that, since I'm dividing by negative, I'm simply going to flip the direction of these two signs. So I have negative 3 greater than equal to x, greater than minus 10. So then on a graph, we have negative 10, negative 3. So see, they've got a flip-flop. They're not in the right order. So negative 10 we cannot choose, but we can choose negative 3. And I want x to be bigger than negative 10 but less than 3. So that's these numbers in here. So then we'll have negative 10 with parentheses, comma, negative 3, bracket. All right. And of course, we have our lovely word problems. So New York City on average has a yearly temperature range of 23 degrees to 86 degrees Fahrenheit. What is the average range in Celsius given F equals 32 plus 9/5 C? Well, the lowest my temperature can be is 23, and the highest is 86. And it can be those, so we'll say greater than equal to, less than equal to Fahrenheit. That's in Fahrenheit. That's our temperature. But I want Celsius, so I'm going to take this and plug it in there. So 23 less than equal to 32 plus 9/5 C is less than equal to 86. Okay, so there's my inequality. I want C left alone in the middle. So we'll subtract 32. Okay, so you have, what, minus 9. Minus 9 less than equal to 9/5 C less than equal to 54. Now I got to get rid of this fraction, so we'll multiply everything by its reciprocal, 5 over 9. Because here, if we look over here, I want 9/5 to become 1. So what do I have to multiply? Well, if I look at its reciprocal, those cancel and those cancel, and I'm left with 1. So I'll take negative 9 times 5/9, which is negative 5, C. And then I have 54 times 5/9, which is 30. So this tells me that in New York City, the temperature ranges from -5 to 30 degrees Celsius. Two car rental companies have advertised weekly specials on full-size cars. Hertz is advertising an $80 rental fee plus an additional 10 cents per mile. Thrifty is advertising $60 and a 20-cent per mile fee. How many miles must you drive for the rental car from Hertz to be a better deal? Well, to be a better deal, we want it to cost less. Okay, so if we have our two companies, Hertz and Thrifty, and we want Hertz to cost less, we're simply going to say this is the cost, and it's going to be less than Thrifty's cost. Well, then I have to figure out, how do I find the cost of each of these? Well, it says right here, Hertz is an $80 plus 10 cents per mile. That has to be less than $60 plus 20 cents Okay, so these are the costs, and it's still want this cost less than this cost. So we'll subtract 60, get 20, subtract 0.1x minus 0.1x less than 0.1x. And then our next step would be divide by 0.1 or multiply everything by 10. So you get 200 is less than x. Okay, well, what does that tell me? This x represents my miles that I'm driving. So I need x to be bigger than 200. So I need to drive 200 plus miles for Hertz to be less than thrifty. Okay, and that's what we want to look at. At 200 miles, these two items become equal. So it doesn't matter which one I go with. At more than 200 miles, this becomes true. At less than 200 miles, this becomes false. So 200 is what we would call a turning point, and we'll get into that later. But it's the changing point of where something becomes true and false. So here's our suggested problems. 101, I believe, is a challenge problem, just a more difficult problem for those of you who feel advanced in this topic. So thanks for joining me. If you got questions, let me know. This is at THS Mr. Jones signing off.